Okay, good morning. This is lesson 1.2 on integers, opposites, absolute values, and evaluating expressions. Please write the title down along with today's date, and we'll get started. All right, now we need to get some definitions into your notebook. So first we have whole numbers. Whole numbers are the set of natural numbers and zero, so they include zero. Integers are the set of whole numbers and their opposites. So the set of whole numbers and their opposites. Examples would be -3 is the opposite of 3, -2 is the opposite of 2, -1 is the opposite of 1, and 0. So those are your integers. So they are the set of whole numbers. So they don't include fractions and decimals. So integers are whole numbers and their opposites. And then you have rational numbers. And rational numbers are they include integers and whole numbers, but they really are more your fractions and your decimals. The official definition is any number that can be written as a ratio. So a rational number is any number that can be written as a ratio, which is the same thing as a fraction. And where b, so you have a over b, and b cannot equal 0. So b cannot equal 0. So where b does not equal 0, because you can't divide by a 0 and get a number that is rational. That would be an undefined number. All whole numbers and integers are rational numbers. So have these definitions into your notebook. All right, we have 4 examples. It says write the following numbers as a ratio. So a ratio, remember, is a fraction. So you're writing all of these as fractions. So 8, that's easy, 8 over 1. So that's a rational number because you can write it as a fraction. So if you can write it as a fraction, it's a rational number. 3.6 is the same thing as 3 6/10. And then, or you can reduce it, it's 3 3/5. Now that's a mixed number. So what you want to do is popcorn that, and you can write it as 18 over 5, which is a rational number. And number 3 is 0.3 repeating. That is a one that you need to memorize as 1/3, and that's a rational number. So all of these are rational. If it can be written as a ratio, as a fraction, it's a rational number. And then number 4 is already written as a rational number. It's a negative number, but it's still rational because you can write it as a fraction. So make sure these are in your notebooks. Okay, other definitions, we talked about this a little bit. Opposites. Numbers that are opposites are 2 numbers that are the same distance from 0 on a number line. Same distance from 0 on a number line. For example, -4 and +4 are opposites. -4 is here, +4 is here, and they are the same distance from 0 on a number line. So we call them opposites. So let's do a couple of examples. Example, if A is equal to -4.8, then we want to find negative A, or the opposite of A. So when you have a negative sign in front of that A, that means we're trying to find the opposite of A, or what I would say negative A. So negative would be, just substitute in a -4.8. So you're doing the opposite of a -4.8. Well, anytime you have a negative of a negative, you get a +4.8. Or you can just think about it on a number line. The opposite of -4.8 would be a +4.8. So if A, for example 2, if A is 5/6, then negative A would be -5.6, or not 5.6, 5 over 6. Okay, I hope that makes sense. Let's go on. Okay, next we have the absolute value. Absolute value is, there's my arrow. Okay, I don't want the arrow. So the absolute value, sorry about that, is the distance of a number line, the distance of a number from 0 on the number line. So it's the distance of a number from 0 on a number line. Ugh, it's so hard to write with a stylus. The symbol for absolute value is what we call the railroad tracks, the two lines that are up and down. This means absolute value. So for examples 3 through 6, example 3, if A is 3, then we want to find the absolute value of A. Absolute value of 3 is how far is 3 from 0? It's 3 spaces. Then example 4 is the absolute value, let A be -5. So if I let A be -5, the absolute value would be a +5. If A is 0, well, how far is 0 from 0? It would just be 0. And if A is 0.25, then notice for example 6, I have a negative sign that's in front of the absolute value sign, which means I want to know what the opposite of the absolute value is, or a negative absolute value. So anytime you have a negative in front of the absolute value, then your answer will be negative. So it's negative 0.25. Okay, so for example 7, 8, and 9, we're going to do both. We're going to give you a value for A, and then we're going to find negative A, which means the opposite of A, and then the absolute value of A. So if A is 6, then negative A would be -6. If A is 6, you find the absolute value of 6 is just 6. So remember, that's how far is 6 from 0. For A is equal to -9.5, if you want the opposite, you want a negative of a -9.5. So you want the opposite of a -9.5. That would be a +9.5. And again, anytime you see a negative like this, that means it's going to be positive. Now the absolute value of -9.5 would be a +9.5. Here we have a fraction for number 9, and we have a -2.56. Again, you want the negative of that. You want the opposite of that. So the opposite would be, again, a negative, so you'd end up with a positive. So it's the opposite. That's what that means. All right, so then we want the absolute value, and the absolute value is always positive because unless there's a negative sign in front of the absolute value sign. I don't know if that makes sense, but I can explain it in class. So get this into your notes. All right, let's talk a little bit about what an integer is. Remember I said that an integer is the whole numbers and its opposites. So let's look at these examples A, B, C, and D and see which one of these might be an integer. So for A, first we have to find the absolute value of a -3.8, and that would be 3.8, it would be a positive. Okay, now this is not a whole number, right? So if it's not a whole number, then it is not an integer. So remember, integers are whole numbers and their opposites. 1/5, that would also be a no. So I'm just writing 1/5 equals no. And then 24/5, the absolute value of 24/5 is just 24/5. Well, 5 does not go evenly into 24, so you would get a decimal if you were to divide. So that is also not an integer. Now let's look at this. Yes or no is, first we take the absolute value of 32/8, and I can divide that out because 32 divided by 8 is 4. But there's a negative sign right here in front of it, so that means it's a -4. Is that an integer? Remember, integers are whole numbers and their opposites, and since this is the opposite of a whole number, then yes, it would be an integer. So you need to be able to know the difference between what is an integer, what is a rational number. All right, we've talked about integers, opposites, and absolute values, and now we're going to evaluate expressions. So the first sentence says a variable. A variable is a letter used to represent an unknown quantity. Common variables are x, y, and n. All right, an expression. An expression consists of one or more numbers and or variables and one or more mathematical operations. An expression consists of one or more numbers and or variables and one or more mathematical operations. An expression does not have an equal sign. An expression does not have an equal sign. Examples of an expression: 1, x minus 2. You have a variable, a math operation, a subtraction sign, and a number. Number 2, 7 times mn is also an expression. And then here, number 3 is also an expression. No equal signs involved. So now what we're going to do is evaluate algebraic expressions. Okay, so to evaluate an algebraic expression, the first step is to substitute the given value for the variable. To evaluate an expression, an algebraic expression, you substitute the given value for the variable. To evaluate means to solve. The next step, okay, and so the next step would be to simplify the expression completely. Those are the two steps that you need to evaluate an expression. Let's see some examples. All right, so for example 4, I don't know if these are numbered correctly, so if they're all out of order, you just go with it. So here we have x is equal to -2, so the first step is to substitute. You have a negative x, so if you have a negative x and you're substituting a -2, that means you have a negative -2. And notice I put the -2 here into parentheses. Plus, then I also have another -2 here. Now I have to evaluate this. So first I do the parentheses, and in here I have a -2. That means I have the opposite of a -2, which is a +2. So that means I'm going to multiply 4 times 2, and then I'm going to add -2 to it. So 4 times 2 is 8. If I add a -2 to that, then I would get a +6. Okay, next, example 5. I'm going to substitute a is a -1/2 and b is 3/4. So I take b is 3/4, then I'm going to subtract a -1/2. Have to get a common denominator. So this would be a -2/4. And I'm subtracting a negative. Whenever I subtract, I keep, change. So keep, change this to a positive, change that to a positive. Add both of those together and I get 5/4. And you can leave that improper in algebra. So we will be evaluating expressions like these. So on to the last example, I believe. So here we have a word problem. It says, this is example 18, where our example numbers are way off, but that's okay. A baseball team's net run score is given by the expression RS minus RA, where RS is the number of runs scored and RA is the number of runs allowed. Using the table below, list the teams in order from greatest to least based on the team's net run score. So you don't need to write the entire problem, but you do need to show some work and maybe write this part. And then what we're going to do for example 18 is we're going to do their net run score. So we're going to take RS and we're going to subtract RA. And I'm going to do the math for you so you don't necessarily have to do it. You're just going to kind of copy this down and just know what to do. So if I subtract RS minus RA here, I'm subtracting 519 minus 451 and I get 68. And then the next one, this subtracting that, I get a -68. Then 503 minus 549 is -46. So you just want to know what they equal. 515 minus 560 is -45. And then 615 minus 528 is 87. So then it says to list the teams in order from greatest to least based on this net run score. So we're going to list the Texas Rangers first. And Texas Rangers had the highest, so they were 87. Then Tampa Bay Rays had a 68. Next, we have the Baltimore Orioles with a negative 45. And the Kansas City Royals had a negative 46. So negative 45 is greater than a negative 46. Remember, as you go on in your to the left on the number line, the numbers farther to the left on the number line are smaller than the numbers on the right. So you kind of have to visualize the number line. And last would be the San Diego Padres, and they had a negative 68. So they had the smallest net run score. All right, that's it for our notes. And thanks for watching. Make sure you have all of this in your notebook.